But hold that thought. We're recording. We are now going to go into additional techniques for evaluating limits. At the end of this lesson, you're going to be able to use the dividing out technique to evaluate limits of functions. You are also going to be able to use the rationalizing technique. You'll also be able to approximate limits of functions graphically and numerically. We've kind of done that already, haven't we? Evaluate one-sided limits of functions. What do you think I mean by a one-sided limit? I'm only looking at as x approaches a number from one side, right? But not the other, all right? This will be on the classroom at the end of the day. Can you close the door behind you, please? Lastly, evaluate limits of difference quotients from calculus. Who remembers what a difference quotient looked like? It wasn't that complex. It was f of x plus h. Now the word difference comes in, which means a what? Minus sign. F of x. Now the word quotient comes in, which means I divide by h. That's a difference quotient. And we're going to be able to evaluate limits of difference quotients. Okay? What do you think the special limit as what approaches what here? As h approaches 0. It's not intuitively obvious what this would be as h approaches 0, does it? Because that means 0 would be in my denominator, right? And we can't have that. So that's what we're going to do. We're not going to get all the way through today. Matter of fact, we're only going to get about halfway today. But let's look at our first technique called the dividing out technique. Okay? First of all, let's consider the limit as x approaches -3 of this function. If I use direct substitution initially, that should always be my first instinct, right, is to use direct substitution. If I use direct substitution here, though, what do I get? What do I get, Jet? Why should I not use direct substitution upon further review? What do you think, Jet? What happens if I put x equals -3 into this function? What do you think, Hannah? Yeah, I have 0 in the bottom, and I can't do that, right? So I kind of come up with another method. Now, one method, and this should give you, remember problem 2 on the graph in the quiz? This should look a lot like that, right? And when we graph it, it looks a lot like the line of y equals x minus 2. Except there's one problem. There's a hole in that function, right? That's what I tried to make abundantly clear right there. So what do we do? To evaluate this graphically, I look at this function as x approaches, and this line right here is -3, right? But as x approaches -3 from this direction, what's my function getting close to? It's getting close to -5, right? Now, as I go towards x equals -3 this way, what's my function getting close to? -5. So what's my limit as x approaches -3? It's -5, right? So here's what I want you to do. Take that function f of x, and I want you to factor the numerator. I don't want to hear what your answer is. I want to see it on paper. I'm going to be walking around, watching, and I want to see you guys factor this function on your paper. We should be taking notes. Note-taking is a good activity in class. Helps keep us engaged. Okay, so now, Hallie, rewrite the entire function except having the numerator factored like you do. All right, now, inside, yeah, that's going to be our next step, right? But keep it on the inside. Keep it on the down low. Because I want everybody to get the benefit of this discovery. As amazing as this discovery is, right, Hallie? It's an amazing discovery. Now, if I look at that, what would be my next instinct? Yeah, okay. Okay, that's what we're going to do next. So it would help to write the problem down at the first, right? Yeah, let's get that written down and see if we can factor that. Well, factor the numerator, right? So now I want to write an equal sign, and then I want to rewrite the numerator except factored this time. Yeah, well, that's a numerator, right? Yes, sir. No? Well, how'd you get the x's? So x times x equals x squared, right? What times what equals negative 6? It's going to be this and this, right?
Yeah. It's going to be -2, right?
Why not 1 and 6?
I mean, it could be.
Or 2 and 3? Well, before you erase it, have some faith in yourself. Now, if you multiply this out, if you did it correctly, what should you get?
I should get x squared plus 1 minus 6.
Not 1x, right? So multiply it out and see if that's what you get. If you get what you started out, then you factored it right?
Oh, yeah. So, okay, yeah, there we go.
Okay. When I factor a quadratic, should look like this, right? Should look like that, right? How do I get my x squared when I multiply a binomial times a binomial? First times first, right? So what does this first and this first have to be in order to get x squared? X and x, right? Now, I get my 6 by multiplying last and last, right? But it's a negative 6. So what do my signs have to be? Plus minus or minus plus, right? Okay. Now, because it's plus and minus, my two factors are going to subtract to be 1. Yes? What two factors of 6 also subtract to be 1? Plus 3 minus 2. If you ask those 3 or 4 questions every time, you should be able to do this in your sleep. And really, we should be able to do this polynomial in our sleep, factoring this. Okay? Now, this is the factored form of this polynomial. What would be the next logical step in your mind? Yeah, so I got a common factor in the numerator as I do in the denominator. That factor is something called x plus 3. I can just go whump and whump, right? So I can tell you without any doubt in my mind that this function equals x minus 2, yes? Ooh, I heard. So So that's a good point. What is this function missing to make it like this function? So it's missing division, right? But we just said that these things cancel out, right? So what gives? When I graph x minus 2, do I get that hole right there? No, so they're not the same function, are they? There's something a little bit off. Would you agree? How would I reconcile that? How would I reconcile that? Maybe set a domain for this guy. Go x can't equal -3. Now they look the same, right? Yeah. Now the graphs of the two would look the same, right? There would be a hole in the same spot in this function as there is in this function, right? They do effectively the same thing. Not really the point of this lesson, but I wanted to make that point just for... but I'm not done yet. Now I got x minus 2. What was the point of eliminating these factors? Now can I use direct substitution to evaluate the limit? So what do I do to evaluate the limit as x approaches -3 of this hot mess? And it's the same right here, right? What do? I plug in -3 wherever I see n x. So -3 minus 2 gets me -5. Is that the same place the hole was in my function down here? Look at that. Look at that. Okay? Let's divide out again. This one doesn't look quite as obvious, but what's our first step always? Well, before I do that, do I want to factor? That's a pain in the butt to factor, isn't it? I want to try direct substitution first. Because if I can direct substitute, if I put 1 in for x, and I don't get 0 in my denominator, can I use it? Of course. Now, let's do that. Let's see if x equals 1 gives me a 0 in my denominator. 1 cubed is? Minus 1 squared? Plus 1? Minus 1 gets me? 0. Dang. That's too bad. But that gives me a clue. What's my clue? X, let's call this denominator, let's call that denominator d of x. What can I say is a factor of d of x? What does a factor of a polynomial look like? Let me ask you this. What is 0 of this function? 1. X equals 1 is a 0 of this function, right? So I'm going to write x equals 1 is a 0 of this function. Now, how did I find factors when I had a root or a 0? Subtract 1 from both sides. That's a factor, right? Remember that from Unit 2? Do we remember even having a vague recollection of that from Unit 2? Yeah. What does that mean? If this is a factor of the denominator, what does that mean? If 2 is a factor of 6, what does that mean? It means when I divide 2 into 6, I get a even number out, right? If I divide x minus 1 into this denominator here, I should get something without a remainder, right? It's the remainder theorem all over again. Who remembers the remainder theorem? We glossed upon it. So what should I do to find the other factor of this polynomial? Yeah, divide by x minus 1. So let's do that. Let's do x minus 1 goes into x cubed minus x squared plus x minus 1. Do I want to do division this way, or do I want to do synthetic division? We can do that. The other class said other way, but we can do synthetic. So let's do that. Let's do synthetic division. It's let's see, it's 1, negative 1, 1, negative 1, right? And what number goes out here? What number goes out here? 1 goes out here. This guy goes out here. Who remembers this? Carry the 1 down. 1 times 1 is 1. Add them. I get 0. 0 times 1 is 0. 1 plus 0 is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. So, remainder 1, x squared. So this is x squared plus 1 is my resultant. Who remembers that? Who could reproduce this if asked to on point? Yeah, it's when can I use synthetic division? How about that, Abby? When can I use synthetic division? When I'm dividing by a, starts with an M, not a monomial. Monomial is just like x. That's a monomial. I'm dividing by a binomial, but what type of binomial? Mon is part of it. Monic. Who said monic? Yeah, monic binomial. What does a monic binomial mean? Who remembers what monic binomial means? What about 1?
One variable.
Not one variable. The coefficient in front of my x is 1. That's where the mono comes from in monic binomial. Okay. Woo! Unit 2. We're in its ugly head. So what's that mean? That means that I'm going to erase all this stuff right here. I'm going to erase my synthetic division because I got my answer right here. So the denominator I can rewrite as, so f of x is x minus 1 over, remember I divided by x minus 1, and that's times x squared plus 1. And I'm evaluating the limit as x approaches 1 of all that hot garbage. Okay? So, now, does anything become apparent to us as far as a plan moving forward? Well, x cannot equal 1 here, but I got a common factor on top as I do on the bottom, don't I? So what can I do? Let's simplify. Let's get rid of those guys. And then what does that leave me on top? It leaves me a 1 on top, right? What's it leave me on bottom? Now, if I plug 1 in for x in that function, can I evaluate it? Yeah. Put 1 in for x. 1 squared is 1, plus 1 is 2, so 1/2, right? So limit as x approaches 1, and I'm just going to call it f of x equals 1/2. You see how we did that? Now, does the function equal 1/2 at x equals 1? No. No. Important distinction there, right? F of 1 does not equal 1/2. What this means is, as you get close to x equals 1/2, or x equals 1, the function approaches 1/2 from either side. But at x equals 1, there's a hole in the function. Okay? You like my artwork there? All right. Now, there's another strategy that we're going to talk about. It's called the rationalization method. We've done rationalizing before, haven't we? When have we rationalized before? One over. Do I like that? No, I do not like that. So what do?
Multiply by the square root of 2.
Multiply by 1.
I multiply by 1, but what does that 1 look like?
Square root of 2 over 2.
Square root of 2 over square root of 2, right? Okay. What do I call that process?
Rationalizing.
Rationalizing the denominator, right? Now, well, let's do direct substitution first. What happens if I do direct substitution into this function? What do I get that makes my hair stand up on end? I get a denominator of 0. So I got to do something, right? So what should I multiply by to rationalize the numerator this time? So, I heard this out there that I should multiply by that. If I multiply my numerator by square root of x plus 1, what do I get?
X at the bottom, you get x equals 1 minus 2.
Well, when I rationalize something, I want to get rid of the square root, right? So let's look at the numerator. Do I get rid of the radical sign when I multiply by this? No. I get square root of x plus 1 quantity squared, right? This times this gets me that, right? But then I got minus. It's this guy that's posing the problem for me, right, Kristen? So I can't multiply by this. What do I multiply by? Wah, wah. What happens when I multiply the top by this? Let's rewrite my limit notation. Yeah, it's kind of like completing the square, right? Or not completing the square, the difference of squares. That's what I meant to say. So, first times first. Square root of x minus 1 times square root of x minus 1. No, or I'm sorry, x plus 1. Yeah, square root of x plus 1 times square root of x plus 1 is x plus 1, right? And then square root of x plus 1 times positive 1, square root of x plus 1, right, Zach? Negative 1 times square root of x plus 1, negative square root of x plus 1. Those guys go bye-bye. Negative 1 times positive 1, negative 1, right? Can I simplify that further, Sam? I got x. I can add 1 and then subtract 1. Where am I at? I'm be at x. So let's get rid of these guys, right? And then I'm just going to leave the denominator in factored form because it's disappointing that I made my fraction bar so janky. Anyhow, so what can I do now? What can I do now? If I do direct substitution here, if I put 0 in for x now, do I still get 0 in my denominator? Yeah, because I got 0 times something, right? And 0 times anything is going to get me 0. But what can I do before I do direct substitution? I can simplify and get rid of these x's, right? So what does that leave on the top? And on the bottom, just the hot garbage, right? So now I got the limit as x approaches 0 of 1 over x plus 1 square root plus 1. Now, put in 0 for x. 0 plus 1, square root of that, plus 1, 1 over that. So the limit, as x approaches 0, of, again, I'm going to call it f of x again, equals 1/2. Okay? That is where we're going to end today. Okay? I'm going to give you your assignment, which is due Friday. Okay? Due Friday. This is a fun assignment. Now, what's that? Yeah, probably. Probably should be ready for that. Probably should be ready for that. So if you want to take the next 5 minutes getting this set up and getting crack-a-lacking on it, I fully support that decision.
How long is each Infinite Hotel video?
5 minutes. We'll watch the last one tomorrow.
I don't get it because I didn't say first 3.
You can watch the first 3. Does that mean you...
I was gone Friday. Okay.
So watch the first 3. The first 3 are like 15 minutes total. 10 or 15 minutes. Oh, you'll have fun. It's a fun video. It's a fun thought experiment. Oh, by the way, I didn't bring this up to the morning class because there was no, we were running behind for some, oh yeah, I had technical difficulties with the whiteboard. The drawing idea for the final project's due today, yes? If you have your idea, send me the stock image in Google Classroom. Okay, let's get good at sending that stuff in Google Classroom, okay? That will give me an opportunity to review it, give you my thumbs up or thumbs down. If you think I might give you a thumbs down anyhow, attach with the stock image a plan or an idea as to how to spiffy it up to meet the requirements of the rubric. Yes, Noah?
Are we going to get work done?
Not in class, no. But you can address questions with us. Dude, you got every Monday off from this class, right? Yes, you do. You got every Monday off from this class. And I have copious amounts of flex time / resource time / prep time / back scheduling time in this room on Monday. So if you guys got questions or you want time to work under supervision, who's got 2 thumbs and would love to watch you work on Mondays?
You.
This guy.
This is still trying finding you on Monday. I've been hacked like 5 bajillion times apparently, though.
Let's not talk about that right now. You had a question, Will?
If we don't send it today, is that okay?
No. You will become a burning ember in the depths of Hades.
I don't know. I didn't think about it, so I have no idea today.
All right.
I have to go play baseball at 2.
You realize that's 10 minutes from now, right?
Yeah. At 2:05, we have to leave early.
Okay.
Yeah, that's all I'm getting.
It's a nice haircut, man. He's not feeling good about his haircut. Give him some positive reinforcement. I think it's the best haircut he's had in several years. Seriously, I do.
Harsh.
No, I like his haircut.
I know, but if he does, that's negative.
It's that. If I say it, it's negative reinforcement just because I'm his dad, but you're his peers. So if you like his haircut, it's positive reinforcement. Isn't that how it works? All right, sorry. Did I cross a line there? All right.